Section 2.7, the last part. Now that we know how to solve absolute value inequalities, let's try to solve one of them. Here is an example before we start solving. So if you have the absolute value of x minus 5 less than or equal to 4, we know that we're going to split this into two. The first part, we're going to keep what's inside of the absolute value intact. Please don't change any signs there. Less than or equal to, we're going to keep the inequality sign, and then we're going to keep the number to the right with the same sign. So we keep. So this is keep. The second half, we're going to keep what's inside of the absolute value bars. We're going to flip the inequality and change the sign of the right-hand side. So keep, flip, and change. Okay? Now, you're going to solve both of these, which is we came up with here. You're going to solve them, and you're going to end up with the inequalities x is less than 9 and x is greater than or equal to 1. You're going to represent them on the number line if you would like to find the answer in an interval notation. 1 is less than 9, and both of the numbers are included. The first inequality says x is less than 9, so we're going to go from 9 to the left. The next inequality says x is greater than or equal to 1, so we're going to go from 1 all the way to the right, which means the answer is the area in between, or the answer is the numbers in between inclusive of 1 and 9. Now, to represent that as an interval notation, we know the circle represents a bracket, and first number is 1 and the second number is 9. Here are some examples. We're going to solve inequalities. We're going to solve absolute value inequalities. Remember, the steps are the same as absolute value equations. So if there is any number added or subtracted or multiplied, we need to remove that before splitting. The 2 here is added, so we're going to remove it by subtracting 2 from both sides of the equation. Subtraction, it does not flip the sign. So do not flip the sign if you're subtracting. Okay, so what we have 2x minus 3 inside of the absolute value is greater than 7 minus 2 is 5. Now we're going to split into 2. So what we have, we're going to keep. We're going to keep, flip, change. So we have 2 inequalities. We're going to solve each one. The first one, we're going to add 3 to both sides of the equation. You will get 2x is greater than 8. And then you're going to divide both sides by 2. 2 is positive, so nothing is going to change. You're going to end up with x is greater than 4. So that is the first part. The second part, we're going to do the same thing. We're going to add 3 to both sides of the equation. We will end up with 2x is less than negative 2. Divide both sides by 2. And in this case, we end up with x is less than negative 1. On the number line, negative 1 is less than 4. And both of them are excluded because there is no equal sign here. The first inequality says x is greater than 4. So we're going to go from 4 all the way to the right because greater. And if you notice, if you write the x to the left, the sign of the inequality tells you in which direction you should head. So the first one tells us to go to the right. And the second one says x is less than negative 1, which means we're going to go from negative 1 all the way to the left or in the direction of the inequality. Again, the interval is going to be the union of 2 intervals. The first interval starts from negative infinity and it ends in negative 1, and both sides are excluded. The infinity by default, negative 1 because we don't have the closed circle there. Union, the second interval starts from 4, the 4 is excluded, and it goes all the way to positive infinity. The next one. So notice here how we have negative 2 multiplied. We need to divide both sides by negative 2 first, and then we can split. Notice how we're dividing by a negative number, which means you're going to flip the inequality sign. So if you divide here by negative 2, here by negative 2, you end up with k minus 4 is greater than or equal to negative divided by negative is positive, so it's going to end up with 3 over 2. Now you're going to flip it into 2. Left side, or the first side, is going to be k minus 4 is greater than or equal to 3 over 2. The other half is going to be k minus 4 less than or equal to negative 3 over 2. We're going to solve each side, so we're going to add 4 to both sides of the inequality. We will have k is greater than or equal to 4 plus 3 over 2. We need similar denominators, so I'm going to put 4 over 1, and then I'm going to multiply the 1 by 2 to turn it into the same denominator, and I need to do the same for 4. So we will end up with k is greater than or equal to 8 plus 3 over 2, which is k greater than or equal to 11 over 2. The other part is going to be k minus 4. We're going to add 4 to both sides of the inequality. Plus 4 plus 4. So we're going to end up with k less than or equal to 4 minus 3 over 2. We're going to do the same steps. Multiply by 2 here, by 2 there. You get k is less than or equal to 8 minus 3 over 2, which is k less than or equal to 5 over 2. On the number line, I know that 5 over 2 is less than 11 over 2. And both of them are included because there is an equal sign. The first inequality says k is greater than 11 over 2. So I'm going to go from 11 over 2 all the way to the right. The second inequality says k is less than or equal to 5 over 2. So I'm going to go from 5 over 2 all the way to the left, which means this interval and that interval are the solution, or the union of both of them. The first interval goes from negative infinity to 5 over 2 included, union 11 over 2 included all the way to positive infinity, and that is the solution. Last one, we're going to add 2 to both sides of the equation. We will end up with x plus 5 is less than 10. Now we're going to split. So you'll have x plus 5 less than 10, unchanged, except for dropping the absolute value bars. We're going to keep, flip, change the sign, negative 10. Now we're going to solve each inequality. We're going to subtract 5 from both sides. We will get x is less than 5 for the first one, and for the second one, we're going to get x is greater than 15. And now we're going to put that on the number line. So 5 here, 15 here, and none of them is included. The first interval says x is less than 5, so all the way to the left, and x is greater than 15, it goes to the right, which means these two intervals, union of these intervals is the answer. So from negative infinity to 5, open, union, from 15, excluded, to all the way to positive infinity. And that concludes sections 2.6 and 2.7.